Hey folks, on the 3.5, number 284, let's see. The concept is easy. It's just weird at first, so don't get frustrated. Am I writing this down correctly? Okay. So they talk about the domain and the range of functions or situations. Sometimes it's called the input and the output, or sometimes we just call it the x and the y. So remember, we have the x comma y. So the domain is just the x's. So 1, 2, 3, 4, 5. These are curly brackets. I don't draw them very well. They look a little bit better here. And the range, I'll draw a good curly bracket. Yeah. Okay. So the range is just the y's. -2, -4, -6, -8, and -10. So think of the x's and the y's as the domain and range as the input and output. So here's the idea. If you tell the computer 1, the computer says -2. If you tell the computer 2, it replies back with -4. So it's like the input, 1, computer says -2. You say 2, it says -4. Okay. So that's a big idea. So that's the domain and the range, the input and the output. So in 280, what do they ask? In the following, I'm looking at 288. In the following, they use a mapping. List the ordered pairs of the relation. Oh God. Find the domain and relation. Find the range. Okay. Well, that's a lot of information there. So I'll just start it out. So 288. So the domain is just all the names. Amy, Carol, Devin, Harrison, Jackson. That's all the domain. Did they ask for that? List the ordered pairs. Oh, okay, I'll start. So Amy, comma, February 24th is her birthday. Next person, Carol, and her birthday is May 30th. I mean, just follow the arrows. What do they want? List the ordered pairs. Okay, ... Find the domain of the relation. Okay, so the domain is just all the names. Amy, Carol, Devin, Harrison, Jackson. And find the range. Okay, the range is just all the birthdays. January 5th, January 7th, February 24th. Okay. So that one wasn't too bad. 292. 292. Okay, so now 292 is getting a little bit more interesting. Functions pass the vertical line test. So in 292, they give us a picture with some blue dots. If I draw the dots, I'm not going to draw them very well. Dot, 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 dot. So if it's a function, it will pass the vertical line test. So I notice right here, it does not pass the vertical line test. So it is not a function. Not a function. So remember when I was explaining a function early on, it's a computer program. So go back to 284. If I say 1, the computer says -2. If I say 2, the computer says -4. If I say 2 again, the computer still says -4. The computer can't get creative. That's what makes it a function. So notice what's happening here. Let me figure out. So this one was the location -3 and 4. And that location right down there was back 3, so -3, -4. So here's why it's not a function. So visually, it does not pass the vertical line test. But if you go back to my idea of it's a computer program, you see how if I say -3, what does the computer reply back with? Does it say 4 or does it say -4? You see how that's confusing? The computer should only say one thing every time. So if there's two possible replies, not a function. And it's easier to see visually with the vertical line test. So if you can draw a vertical line and hit the picture in two places, then it is not a function. So had this dot not been here, then I could not have drawn a vertical line and hit two dots, and so it would have been a function. But because I can draw a vertical line and hit two dots, not a function. Oakley dokley. Let's see, 296. So 296, they just want you to actually plot those points. So rather than giving you the picture, you have to plot the points and then try and do the vertical line test. Okay, and then I told you to skip 303 and 305. Okay, 307. Now it's getting interesting. 307. Function notation. So it seems like all we're doing is replacing y with f of x, and that's kind of what we're doing. Did I say 307? I meant 308. F of x is equal to 3x plus 4. And it's essentially just y, but let's think of it like a computer program. So they want you, in question A, to give the computer program, so you tell the computer 2, and then the computer replies back with this idea. So 3 times 2 plus 4, 6 plus 4, which is 10. So you give the computer 2, you give the function 2, and it replies back with 10. Okay. Question B, what if you tell the computer -1? So the input is -1, and then the computer replies back with 3 times -1 plus 4. This is the function. So -3 plus 4 is 1. Okay, and then C, you say A. That's weird. Computer doesn't care what you tell it. It's just going to say 3A plus 4. Oh, okay. That makes sense. So, kind of how we do an x and a y coordinates, right? We normally would have said, let's just do this. We have x and f of x. So if x is 2, then the f of 2 is 10. See how essentially it's just the x, see how the x we plugged in 2, so x is 2, and then the f of x, that's now the y, is 10. Okay, so if we give the function a -1, then the function spits out 1. So yeah, isn't it just basically x and y? Pretty much. It's a little bit weirder, but essentially that works for now. Okay, straightforward. Okay, 316. More papers. 316. G of x. So f of x, g of x, w of x. Letter doesn't matter. 5x minus 8. And the first thing we give it is, so g of h squared. So remember, you can tell the computer anything you want. Hey, something weird, h squared. Okay, what does the computer do? Whatever you give it, it's going to multiply it by 5. Okay, and it's going to subtract 8. That's all. And it doesn't really clean up. It's done. Okay. So I can give it anything? Yeah. What if I give it x plus 2? Okay. Well, it multiplies it by 5 and subtracts 8. Whatever I give it, it's going to multiply it by 5 and then subtract 8. 5x distribute, right? 5x plus 10 minus 8, 5x plus 2. Little weird at first, but just do all your homework. It'll start making sense. So instead of this, what if we first give it x, and then we give it 2, and then we say, hey, why don't you add them together? So g of x, well, that's kind of easy. It's just this function, 5x minus 8, plus g of 2. Okay, well, what if I have 2? So up here, g of 2, so that means 5 times 2 minus 8, 10 minus 8, which is 2. So 2. So g of x is just 5x minus 8, okay. And then g of 2, I kind of did it off to the side up here, is just 2. And then clean it up. 5x minus 6. So I think what the book wanted to show was that g of x plus 2 is different than g of x plus g of 2. Okay. This was pretty straightforward, I think. Let's do another one. Let's see, in 3.5, we're going to go up to 331. Okay. Let's see. 328? Sure. 328. G of x is equal to x minus 2 over x plus 2. And they want us to figure out g of 4. Okay, so that just means plug in a 4 wherever you see x. So that's just going to be 4 minus 2 over 4 plus 2. And then reduce it, 1/3. Okay, not bad. Hopefully that was straightforward. And then I guess we'll try 330. Let's see how ugly that one can get. 330. 330, we have a function, n of t is equal to 43 plus t. Every day a new puzzle is downloaded into Ken's account. Right now he has 43 puzzles. The function, blah, 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 represents the relation between the number of puzzles and the time in days. Okay, determine the independent and dependent variable. Oh my gosh, the x and then the y, which we call the y. So the x is the independent, and this is the dependent. So basically, your f of x, whatever number that turns out to be, depends upon what x is. So if this is the dependent, then this would be the independent. Why do they name everything? To drive you crazy. But that makes sense, right? This variable, the f of x, depends on what x was. Okay. And so the x happened to be the t. T, the independent was t, time, measured in days. And then the y happened to be the n, or n of t, which is the number of unwatched shows. Whoops, number of puzzles. I was looking at the wrong problem. Number of puzzles. Okay, so that's part A. And then part B, find n of 30. So n of 30, what does that mean? That means time 30. So in 30 days, how many puzzles will he have? So that's just going to be 43 plus t, 30. He should have 73 puzzles in 30 days. Okay. So I guess we're ready for 3.6 graphs of functions. Moving right along. I guess I get to save some paper. Let's see. Hang on, folks. I'm getting there. I'm scrolling down. Oh my god, look at all these examples. Okay. Aha! 338. 338. I see a picture that looks like that. And they want to know, what do they want to know? Is it a function? Oh, so it's just a vertical line test. That's fun. Okay. So part A, can I draw a vertical line and hit it in 2 places? No. Function. That's it? Yeah. B, circle. Can I draw a vertical line and hit the picture in 2 places? Yeah. Here, maybe here, here, bunch of places. Okay, so this thing is definitely not a function. Not a function. Okay. And then, let's see. 342. What does 342 want us to do? Graph each function, state its domain and range. Write the domain and range in interval notation. Oh, silliness. 342, f of x equals 2x plus 5. So, f of x, just think of it as y. So think of this as just y equals 2x plus 5. 1, 2, 3, 4, 5. Put a dot. How do I get to the next dot? Slope of 2, which is 2 over 1. Up 2 over 1. Up 2 over 1. So we get something that looks like this. And then the domain, D, and the range. They want it in interval notation. And so that would be domain. I'm going to do an example in 1 second that's going to make this more clear, but for right now, just go with it. The domain is the x stuff. So it looks like this line goes forever in both ways. So it's just from negative infinity to infinity. And then the range, it goes forever in the y direction. So that's from negative infinity to infinity. That didn't make sense? Yeah, I know. Just go with it for a second. Okay, so here's an example. 1, 2, 3, 1, 2, 3, 1, 1. So I'm just going to do sort of a picture that looks like this. Okay. So now, here's a picture. This will help clarify things. What's the domain and what's the range of this picture? So the domain is x stuff. Nothing, 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 nothing. All of a sudden, picture, 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 till right there, the nothing, nothing, nothing. So the domain is going from negative 3 to 3. That's where picture exists. And there is picture at negative 3, so bracket. And there is picture at 3, so bracket. Range, remember D before R alphabetically, just like X before Y. So the range is Y stuff. So nothing, 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 and then all of a sudden picture, 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 till about there, then nothing, nothing, nothing. So range goes from 0 to 1. Starting to make a little bit more sense. Okay, so now, now they do that game. Okay, so in 378, they give us a picture, and it looks like it goes from negative 3 right there, dot, and then it goes out like that. Beautiful, beautiful, beautiful. Domain, range. Okay. This is one of those things where at first you're like, what? But then once you see it, you'll be like, oh, okay. So with the x stuff, the domain, go from left to right when you sweep across, right? From negative to positive. Do the same thing with range, from negative to positive. Okay, so domain. There is nothing, 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 nothing. All of a sudden, picture, 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 and the arrow means it's going forever. So the domain, there's picture in the x, in the domain x, from negative 3 to infinity. Is negative 3 included? Yes. Bracket. Infinity, you can never touch. Range, nothing, 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 nothing until right there. Range is the y component. What's the height there? 0. Is 0 included? Yes. 380. 380. We have a picture, and it looks like it's down to, is that going by 2s? 2, 4, 2, 4. So this is at 1, negative 1 there. And there's a picture that looks like this. Okay, try this on your own, and let's see what you get. Domain and range. Okay, so domain. See, the arrows mean it's going forever, and the arrow is forever. So there's picture, 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 picture. So the domain is from negative infinity to infinity. You can't touch infinities, so parentheses. And then the range, nothing, 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 until about negative 1, and then picture, 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 picture. So from negative 1 to positive infinity. I'm actually touching negative 1. Can never touch infinity. Whew. Okay, hopefully that's making sense. 384. Blue paper. 384. They give me a weird looking picture. 1, -1, pi, negative pi, and then the picture goes here, 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 here. So it's kind of doing a wave thingy. Okay. F of 0. Function is our picture. At 0, when x is 0, what's our function height? -1. Okay. B. What's the function height at pi? At pi, here's pi, and we are up to 1. Okay. C. F of -pi. The picture, what's happening at -pi? At -pi, the function height is 1. Okay. D. Find the values of x when f of x is 0. Oh my god. F of x is 0. F of x is the height. Let me draw a little bit more. 2 pi. So between 1 and 2 is 1.5. 3/2, 1.5. -3/2. Why would they give such a weird example? Okay, f of x is 0. That means when the height is 0. Where is the height 0? Where does the function have a height of 0? Here, 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 and here. So when does the function equal 0? When x is halfway to pi. That's tricky. Halfway to pi. Care if I just call it pi over 2? Pi over 2. And then that place, which we said, I didn't write it very well, was 3 pi over 2, 1.5. Why do they give such wacky numbers? And then also over here, that's negative pi over 2. And then this one over here is negative 3 pi over 2. F of x, when does f of x 0? When does the picture have a height of 0? At that spot, that spot, that spot, and that spot. What are those locations? Oh, those are the locations of pi over 2, 3 pi over 2, negative pi over 2, and negative 3 pi over 2. Okay. E. X-intercepts. X-intercepts. Oh, this is my x-axis. So the x-intercepts is just these answers again. The x-intercepts is just when the function height is 0. So the same answers. So D and E should have the same answers. Okay. F. The y-intercept. Where do I cross the y-axis? Oh, right here at -1. Okay. G. Ooh, domain and range. Okay, so G is the domain. H is the range. Okay, the domain. They have little arrows. So things just keeps kind of fluctuating like that, right? It's just a little wave. So it looks like it's going forever because of the arrows. So the domain, -infinity to infinity. And then the range, you'll see that it's a wave, and it kind of goes up to 1, down to -1, up to 1, down to -1. So the range is, it's always between -1 and 1. Oh my, oh my. Okay. We're going up to 385. Oh, so we're good. Okay, sweet. Do your homework.